In this lecture, we will talk about the exact solution of this advection equation. In previous video, you saw that we have derived this advection equation, and you can also see that there is an initial condition. So this is very important to find out the exact solution. Let me just talk about this advection equation first. This Q over here, remember that can be a density, can be a pressure, so on. For example, if Q is a density, then this becomes partial rho by partial T plus U bar partial rho by partial X is equal to 0. It means that this density of the fluid can be a anything, maybe water or air or so on. So that the density of the fluid is just moving with some velocity u bar. Okay. Now we want to see the exact solution. In mathematics, sometime we discover an exact solution by the look of by the properties of some equation. In this case, we have advection equation. So let me just try a solution. You remember in your previous course, or probably you have seen that if you have a wave equation, then you remember that there are two solutions. One is right moving wave and another is right and left moving wave. Is depend what is C. If C is, for example, greater than 0, then we have a right moving wave. If C, and similarly it is a left moving wave. When there is a negative sign, the wave move from left to right. From this information, we can also find the solution of this advection equation, and I just need to remove that since I want to solution for general Q, and the solution will be Q tilde X minus U bar T. This wave equation is second order differential equation and there are two waves. This advection equation is first order in space and first order in time. So it has only one wave solution, one wave solution. In this case, we assume that U bar is greater than 0. The wave will be moving from left to right. If my claim is this is a solution and the solution always satisfies partial differential equation, in this case it is advection equation. So what we do, we put this exact solution into the differential equation. So first I define, let xi is equal to x minus u bar t. Since x depends on x and t, so xi xi is a function of x and t. First I compute partial and I put this value over here. Q is equal to Q tilde. Q tilde is coming from the initial condition. Sometimes people call initial condition by Q naught. Q naught or sometime like this. So Q tilde will be a function of xi and xi will be a function of x minus u bar t. In this lecture, we will not talk about this particular case, but just to find the exact solution. In future, there is a particular name for this thing. In that case, it is called characteristics, and we will talk about that in future video. So first I calculate partial q by partial t, partial q by partial t, that will be partial q tilde by partial xi and partial xi by partial t, which will be equal to partial q tilde by partial xi and partial xi by partial t will become minus u bar. And this is equal to minus u bar, which is speed, partial q tilde by partial xi. So first we computed this partial q by partial t. Now we compute partial q by partial x. That will be equal to partial q tilde by partial xi. Then we have partial xi by partial x. Partial q tilde by partial xi, and the derivative of xi with respect to x is 1. So that will be equal to partial q tilde by partial xi. We put this into the advection equation. Partial q by partial t plus u bar partial q by partial x. Partial q by partial t will be equal to minus u bar partial q tilde by partial xi plus u bar, and the value of partial q by partial x is partial q tilde by partial xi, and as you can see that the right hand side is equal to 0, so it means that this satisfies this solution or this solution satisfies the advection equation, and we got the solution over here. It simply means that the solution in advection equation just move. If we have this wave, then this wave will move towards the right if u bar is greater than 0, like this. Then we have, after some other time, we have this wave like this. So wave moves from left to right. So here we just saw that the solution is x minus u bar t. For example, if we have partial q by partial t, u bar partial q by partial x is equal to 0, and qx0, which is an initial condition, that will be equal to sine x. We simply write the solution qxt, since this is just initial condition. The exact solution will be x and t sine. According to this theory, your initial condition should be in your initial condition you put x is equal to x minus u bar t. So this will become x minus u bar t. If the speed of wave is 2, then the exact solution becomes sine x minus 2t.